Alright friends, before we get into a summary of the elevator activity, I just wanted to talk really briefly about how to use Newton's second law. Yesterday in class during our review session, there were quite a few people who asked for the formula for the normal force or the formula for the tension force. And it's really important that we understand that there is no formula for solving for the normal force. There is no formula for solving for the tension force. We only have this one equation, which is Newton's second law that you see here. And essentially, Newton's second law is not just an equation, but it's a set of instructions that tell us how to solve force problems. So essentially what you're doing is writing down Newton's second law, net force equals ma. And if you were to divide this equation right down the center, then on the left side of your equation, you have a set of instructions that tells you to draw your free body diagram. And then depending on what your free body diagram looks like, you would add up all the forces that you see on your free body diagram within the box that we just drew. On the right side of the equation, you would plug in the mass and the acceleration of the system. So what that means for us is that depending on your problem, depending on your free body diagram, what goes into this box here will change for every single problem. And the way that you figure out what goes in the box is by looking at your free body diagram. So let's say, for example, for one free body diagram, we have the following forces. We have an applied force to the right and a frictional force to the left. Then when we are writing down net force equals ma, what goes on the left side of the equality, let me just add that equal sign there, would be the applied force minus the frictional force if we made to the right positive. Now let's take a different example. Maybe the box is being pulled by a string, not being pushed. So maybe there's a tension force and it's on a frictionless surface, so there's no friction. So maybe our free body diagram looks like that. Then for this problem, what goes into the box is just Ft. Now let's say we have a box where there is friction on the surface, and there is also a push on the box, so maybe there's an applied force. And let's just say this is a very strange situation where not only is the box being pushed from the back, let's say the box is very, very heavy, it's also being pulled at an angle. So let's say that this box has some kind of tension force at an angle theta. Well, in that case, this free body diagram would have a second force in the x direction that would be the horizontal component of that tension force. So that would be t cosine theta. So we would have to include that force on our box. So maybe this is our free body diagram for yet a third problem. In that case, we would have to look with our eyes at the free body diagram and we ask ourselves, what forces exist in the x direction? If there's 3 forces in the x direction, all 3 of those forces need to show up in this gray box. So if we make to the right positive, then we would write down Fa plus t cosine theta minus the frictional force equals mass times acceleration. So essentially what I'm trying to say here is that there is no set formula for net force equals ma. What goes on the left side of the equation will change every single problem. And the way that you figure out what goes on the left side of this formula, essentially what goes into the gray box, is by drawing your free body diagram and looking at your picture and saying how many forces are acting in this direction. And you have to look in only one direction at a time, either in the x or in the y, because remember, just like in kinematics, we can only compute formulas in x or y. right? We can't take a vector that exists in 2 dimensions and plug it in anywhere. So I hope that clears things up for you just a bit in how to use Newton's second law.